Okay, we're going to look at solving one-step inequalities. When you do this, it's very, very similar to just solving a regular equation. But let's look at, first of all, what makes a true statement with these inequalities. So on the first one, we're given that 4 is greater than 2, which we know to be true. Now, we're going to treat this just like it's an inequality, so remember what you do to one side, you do to the other. So we added 3 to both sides. So now we have 7 is greater than 5, and that's true. All right, what if we subtract 3 from both sides? We get 1 is greater than negative 1. That's true. What if we multiply 3, both sides by 3? Well, we get 12 is greater than 6. That's true. All right, down on the bottom we have 4 is greater than 2. Yep. Multiply it times negative 3 now. All right, now when we multiply it by negative 3, we're going to get negative 12 is greater than negative 6. No, that is false. All right, what about 4 divided by 2? 2 is greater than 2 divided by 2, which is 1. That's true. But now look what happens when we divide by a negative 2. We get negative 2 is greater than negative 1. False. So what happened when we divided or multiplied by negative numbers? We ended up with statements that were false. So what do we need to do to make the statement true? Well, if we flip the negative sign, do we now have a true statement? Yes. Does it work over here on this one? If I flip this negative sign right here, I get negative 2 is less than negative 1. So flipping or changing the direction of the inequality sign, I changed that from a false statement to a true statement. So our conclusion should be that when multiplying or dividing by a negative number or a negative coefficient, flip the inequality sign. The other thing that you can do is just go ahead and multiply the whole equation by negative 1, and then you don't have to worry about flipping it. All right, we're going to look at just a few examples. On this one, we're going to solve it exactly the way we would normally solve any equation. I'm going to add 2 to both sides. And that makes a 0 pair. We cross it out, bring down our y, and we have y is less than 8. Now, to graph it, we draw our number line. I'm going to put an 8 here. We don't have to be real careful on this. Put a 0 here, and then come over here and put a negative value. Just pick one that you think looks pretty. All right, where are we starting? We're starting at 8. It is less than. There's no equal bar underneath it, so I need an open circle. And my line goes in the same direction. This way. Okay? All right. All right. Number 2, let's look at number 2. This is 3r is plus 17 is greater than or equal to 2r plus 14. All right, we need to get our variables on one side, so I'm going to subtract 2r from both sides. Okay? That comes out, gives me 1r plus 17. And those are a 0 pair, is greater than or equal to 14. Now I'm going to undo this addition. Minus 17. R is greater than or equal to negative 3. All right. This time I have a 0. I have a negative 3. I'll put a 3 over here. I'm going to start at negative 3. This time, because negative 3 is part of the solution set, we need a solid dot. Now, we draw our arrow in the same direction the inequality sign is going. So as the inequality sign is pointing to the right, my line is going to go point to the right. All right, I'm going to skip down to number 4 for you. Let's take a look at this one. On this one, we are multiplying by a negative number. So what I want to do, so that it comes out to be a true statement, and I'm just going to do it right now, I'm going to multiply the whole mess by negative 1. So now I'm going to have 8p. That means I flip everything. I flip all of the signs, and I turn my inequality sign. And that negative 32 becomes a positive 32. Now I'm ready to solve it by saying p is less than 32 divided by 8. So p is less than 4. Again, let's just graph it real quick. I'm going to start at 4. 4 is not part of my solution set, so I need an open circle. The inequality sign points to the left, so the arrow on my graph goes to the left. All right, same thing here. Multiply both sides by negative 1. So now I get k over 4 is less than negative 2. Notice I just changed all of the signs, including flipping that. All right, so now we're going to get k is less than negative 2 times 4. So k is less than negative 8. And let's graph it. All right, here's 0. Here's negative 8. 8 is not part of the solution set, so open sign and points to the left because that's the way that went. All right, one more. 3/4 of m is less than or equal to negative 18. Remember that when you've got a fraction, what we need to do is multiply by the reciprocal. Okay, that's going to clear that out. And I get m is less than or equal to negative 18 times 4. So if you put it in your calculator, actually let me just show you real quick. I can do this 18 over 1 times 4 over 3. That simplifies to 6 over 1 times 4 over 1, and that is 24. So just real quick, graphing it, 24, 0, negative 24. This time we have a less than or equal to bar, so 24 is part of my solution set, so I need a solid dot and draw like that. All right, that's how you do one-step inequalities. Now you need to go on and finish the rest of this on your own.